So today we're going to go over interpreting structures of equations, and this is an important unit and lesson so that we can understand some of the things that are going on later in the year. Our objectives today, our goals, are to be able to explain some vocabulary, some things such as terms, like terms, coefficients, constants, and variables. We're also going to be able to identify monomials and polynomials, reduce monomials to their simplest form, and name and classify polynomials. So jumping into the vocab, we're going to go over a constant. Now a constant is a number all on its own. Some common constants that you might have already been exposed to are the constants 1, 2, 10. Let's through some weird ones in here. Pi is a constant as well. 2020 is a constant. All of these things are single numbers, even though they might have more than one digit, and they're all alone. So the biggest thing that we can think about, and the reason why it has its name constant, is because these numbers don't change. 1 will always equal 1, 10 will always equal 10, and 2020 will always be 2020. If you need some help remembering this, you can always think of constants being Beyonce, because Beyonce is always going to be Beyonce, and she wrote the song Single Ladies. So single, number, constant, Beyonce. Another thing about vocab are about variables. And variables are symbols for numbers that we don't know yet. They're also called an unknown. So what do we know about these? Well, the most common one that you've probably run across is x. You've also probably seen y. Let's say that x is, for our case, we're going to have it represents apples. So it's a number that we don't know yet. We don't know what the number of apples we have, we just know that it represents apples. Let's do y representing the number of oranges. We'll remember this later on. So if we can use variables to make our life a little bit easier, say we know that each apple costs 50 cents, and we want to spend $2. So if we want to make our life easier and find out how many apples we are allowed to buy with our $2, we can just put in an x there. So we have 0.5 times the number of apples is equal to $2. And we can solve that really easily. And really, variables, they can be any type of symbol that you want. We have x and y. You might also see z sometimes. U, v, and w. S and T. You could also see some things in Greek because mathematicians ran out of letters and they just had to use some extra ones from a borrowed language. So you might see theta, which usually represents angles. You might also see something along the lines of mu or phi or omega. And remember, these are just extra letters that we have, and we can use them to represent things that we don't quite know yet. Our next vocab is a term, and a term is a single number variable or a number times a variable. There should be a comma in there. And so, for example, our constant 10 is a term because it is a single number. Our variable x is a term because it is a single variable. We can also have 10x, and that's a term because you have a constant or number times a variable. Now, if we have 10x plus 7, this entire thing is not a variable, or not a term, but 10x is a term, and 10 is a term, and 7 is a term. So you can make things out of terms, and just know that the term is just that one chunk of the bigger picture. Another thing that we can go over is like terms, and like terms are terms that are similar to each other. They have the same variable or a symbol representing a number, and they have the same power on the variable. An example of this is going to be 3x and 7x. 3x and 7x have the same variable, and they also have the same power, which is 1. We just don't write it because it's easier to keep out the 1. So because 3x and 7x have the same variable and the same power, they are like terms. Now we're going to do a counterexample because sometimes it's easier to do a counterexample. So let's stick with that 3x, but instead of 3x and 7x, we're going to do 3x and 7y. Now remember that x was apples and y was oranges. So if you're looking at these, you have an x and a y, you have 3 apples and 7 oranges. Although they still have a number and a variable and they're multiplied together, they're not like terms because apples are not the same thing as oranges. Just as x is not equal to y. Another good example here, and we're going to do this for the power, is that x squared and x to the cube are not like terms. And there's a good reason for that. If you were to draw out how you multiply these things, you'd put an x on one side and an x on another. And so when you multiply them out, you get x squared, and you get a nice little square. Now, if we're doing x cubed, what we're going to do is we're going to have an x on one side and x on the other side. And then we have the problem of this x coming up on the top. So not only do we have that square originally, we now have a box or a cube, and inside that cube it has a volume of x cubed. So what that means is when you're trying to say that they have, if you're trying to say that like terms have similar powers, it means that they're talking about the same thing. X squared is talking about a square with x's on both sides, and x cubed is talking about a cube with x's on all 3 sides. And so a square is not the same as a cube, and so you can't call them like because they're not the same. Finally, for our vocab, a coefficient is a number multiplied into a variable. And it's really just a fancy term to help you understand how things are going. So let's go back to our 3x. Let me change here. Our 3x. So our variable here is our x, and our coefficient is that number 3. So that's our coefficient, the number 3 being multiplied into the variable. And you can have really wacky coefficients, like you can have 105x. And so that 105 is a really wacky coefficient. You can also have coefficients on different types, on like even crazier things. So let's say that we have 20x to the 4th. So even though x is raised to the 4th power, or its exponent is the 4th power, the 20 is still our coefficient, just like the 105 was and just like the 3 was. Now we're going to take a quick break here to do a quick check. And what I want you to do is to work on these, like pause the video, work on these. And I want you to take a moment to name the highlighted part of each example. So I'm going to work this first one out here for you, and just as a quick sidebar, you'll notice that some of these have stars. Those ones that have stars are the ones that I really want you to do. If you can't do anything else, I'd like you to at least try those ones, because those ones talk about some of the most important things that we've been discussing today. So our example here of 3 plus z is equal to 7, the z is highlighted, and so that is going to be our variable, because it stands for something that we don't know yet. Here, I want you to think of all of it together. So I know that it has a lot of different parts to it, but I want you to think of the entire thing together. So go ahead and pause, and then we can come back, and we'll talk about this a little bit more in class.